Hi, today's lesson is going to cover polygons. So a polygon is a closed plane figure containing three or more angles and is bounded by three or more straight sides. So we've got a triangle, a square, that's a quadrilateral or parallelogram, and so forth. All of those in that first row are polygons. They can even be concave like this, as long as they're straight on each side. A circle or something with a curved side is not a polygon. In the general polygon, the vertices are the points where each side meets. So those are the vertices. And then the sides are the straight line segments there. And a line segment is a finite portion of a straight line. So it has two endpoints. It actually has a beginning and an ending. Lines themselves go on forever and ever. There are diagonals in a polygon, and those are any line segment that can connect vertices. So like AD here or AC, or we could draw BD or EC or EB. I think that's about all of them in there. Example 1 says, consider this polygon, and we call it UVWXYZ because we name it by its vertices. And you can start with any vertex, just make sure that you're going in order around the polygon when you name it. It asks us to list the sides, the vertices, and the diagonals. So the vertices are U, V, W, X, Y, and Z. The sides are all along, so UV, and we put a little line segment on top to show that it's a line segment. And we've got VW, WX, XY, ZY, ZU, and UV. And it doesn't matter. You can call line segment, say UV, you can call it, oh, I've got an extra one on there. Yep. Because UV and UV are the same. But you can call UV also VU. Either way will work. And then it asks for the diagonals. So we would start, I'm going to start with U and go around. So UW, UX, and UY. And then with V, we would have VZ, VY, and VX. With W, we've already got WU, and we need WZ and WY. And that might be all of them. I think each vertex should have 3 coming out. Let's see, Z does not. We need ZX. Okay. And I already pointed that out. The perimeter of a polygon is the distance around the sides. And to find the perimeter of any polygon, you just add up the distance of each side. So for example 2, we would add up each segment. So first we have KL, that's 3 inches, plus LM, 5 inches, plus MN, 6 inches, plus NK, 4 inches. And that is 18 inches. Quadrilaterals. A quadrilateral is a polygon with 4 sides. And a parallelogram is a quadrilateral whose opposite sides are parallel. So in this picture here, there's a lot of blue in there. That is the parallelogram, except for I didn't do very good down there. And sometimes you might see parallelograms are denoted, or parallel lines are denoted with little triangle type things. So like we could say that AD is parallel to BC by making triangles. And so if we wanted to say AB is parallel to DC, then we need to put 2 triangles on there. A rectangle is a parallelogram where 4 angles are right angles. And yes, the opposite sides are equal, but the definition is that you've got 4 right angles. And then a square is a special rectangle where all the sides are the same length. A trapezoid has 2 parallel sides. So MN and PO here are parallel, but MP and NO are not. And you can have a quadrilateral that is not a rectangle or a square or a parallelogram or a trapezoid. That's this picture. Area is the number of square units of surface within the figure. So it's everything on the inside, okay, all added up. And so if we were to divide this 4 by 5 rectangle into little 1-inch units, then you would see if you add up all those 1-inch units, you get 20 of them, which is the same as multiplying 4 by 5. So that's why you can find the area of a rectangle by multiplying the length times the width. And there's our formula. And I've made a nice formula sheet for you to be able to look back at anytime during the course. Find the area of this rectangle. Well, we'll call the area A, and we'll just take the length times the width. So 45. Well, let's go back here a little bit. The length is 9 inches and the width is 5 inches. So 9 times 5 is 45, but we need to take into account the units. And we can't just write 45 inches because we have inches times inches. And we discussed this some before. If you multiply inches times inches, then you have inches squared, or the way we've been writing it is square inches. In technical work, it's important to both state measurements and round calculations to the proper precision and accuracy. However, people do not normally state quantities with the exact accuracy with which they've been measured. For example, the length of a box might be measured accurately to 2 significant digits, but a carpenter would write it as 9 inches rather than 9.0 inches to avoid confusion in calculations. So either state your unrounded answer or follow the rounding instructions that accompany the problem. You can find the area of a rectangle, of course, by doing area equals length times width. If you're given the area of a rectangle, then you could find the length by solving for L. L would be A over W, or you could find the width by solving for W. It would be A over L. So in example 4, it says a rectangular opening 12 inches long must have the same total as 2 smaller rectangles or two smaller rectangular vents, 6 inches by 4 inches and 8 inches by 5. What must be the width of the opening? Well, what I like to do to start with is to draw a picture. So here's the larger opening, and it's 12 inches long. We don't know its width, so I'm going to call its width. Well, let's call it W. That would make sense. It's W inches. And then we've got a 6 by 4 vent. And an 8 by 5 vent. Not drawn to scale, but I tried to get it close. Okay. And so we can find the area of these two bottom figures. The area of the first one would be 6 inches times 4 inches, or 24 square inches. The next one would be 8 inches by 5 inches, or 40 square inches. And so we can add those and get the total area. Which is 64 square inches. So we know that this whole figure there, the bigger rectangle, has to have an area of 64 square inches. And so now we can use this information to find W, because we've got area equals length times width. Or let's see, we're using capital letters, aren't we? So the area is 64. The length was 12. I need to add in the units here. And we don't know the width. I'm going to do that in a different color. Okay. So let's see. Do I have another page? Nope. Move some things around. I'll pause. Okay. So we've got the formula W equals A over L. And we can plug it in this way. Or we could have divided both sides by 12. But I'm just going to do it with this formula. And 64 divided by 12 would be 5 1/3. And the square will go away, and the inches on the bottom will go away, leaving us with just inches. So the width of the larger rectangle would be 5 1/3 inches. The perimeter of a rectangle, of course, you just add up the sides, or you can use this formula, which is 2 times the length plus 2 times the width. Because, of course, if this side is W, then this side is W, and if the length is L, then that's the length too. Okay, so let's find the perimeter of this rectangle using the formula. So it'd be 2 times 7 plus 2 times 3. Or 20 inches is the perimeter of this rectangle. The area of a square, well, the area of a rectangle is length times width. So if the length were S and the width were S, then the area would be S times S, or S squared. because the sides are the same. So if the area of a square would be s squared. The perimeter of a square would just be the length of one side times 4 because all the sides are equal. Find the perimeter and area of this square. So the perimeter would be 4 times 9 inches or 36 inches. And we're actually dealing with feet. Sorry about that. And then the area would be 9 feet squared, which is the same thing as 9 feet times 9 feet. 9 times 9 is 81, and feet times feet is square feet. If you have the area of a square and you need to find the length of the side, then you can use the fact that if you have that the area is side squared, to get rid of a square, you take the square root of both sides. And so you're left with the square root of A being the length of the side if you've got the area. Example 7 says if a square opening is to have an area of 64 inches squared, what must be its side length? So here's my square, kind of, and its area is 64 square inches. So the side will be the square root of the area, or the square root of 64 square inches. The square root of 64 is 8, or negative 8, but obviously side's not going to be negative, so we just go with the positive. And the square root of square inches is just inches. The area of a parallelogram is the length of the base times the length of the height. Realize that a parallelogram, well, a rectangle is a parallelogram, but if you take a parallelogram and just kind of do this, or you take a rectangle and kind of tilt it, then it's the same thing as length times width, because you have the length, which we're now calling the base, and the width, which we're now calling the height. So in this parallelogram, find its area, its base times height, or 7 inches times 10 inches. We don't need the 12.2. 70 square inches. The perimeter of a parallelogram is just 2 times each side added together, just like with a rectangle. So in this picture, the perimeter would be 2 times 24 centimeters plus 2 times 18 centimeters. (84 centimeters). There's just a list of all of them. For trapezoids, the area of a trapezoid is a little bit different. It is the average of the bases times the height. I like to say that rather than memorizing this formula here, b sub 1 plus b sub 2 divided by 2 times h, or half of h times b sub 1 plus b sub 2. You can memorize the formula, but the fact is it's the average of the bases times the height. And the bases are the two parallel sides. Even though this one is on top, we still are calling it a base. And the perimeter, add up the sides, of course. So find the area and the perimeter of this trapezoid-shaped metal plate. The area, I'm going to use the formula h over 2 times b sub 1 plus b sub 2. So the height is 6. And the bases are 7 inches and 19 inches. So we have 3 times, oh, I forgot my inches there. Times 26 inches. That is 78 square inches. And then the perimeter, add up the sides. So we have 8 plus 7 plus 9 plus 19. 43 inches. A few more examples here. Example 11 says, what is the cost of fencing a rectangular playground measuring 45 yards by 58 yards at a cost of $16 per foot? So again, let's draw a picture of this playground. And we are fencing it. So would we use the area or the perimeter? The perimeter. And it is 45 yards by 58 yards. So 2 times 58 plus 2 times 45. Okay, so there's the perimeter, and it says that each foot costs $16. Well, we got one problem here. We're in yards, not feet. I do have another page. Okay, so we found that the perimeter is 206 yards, and we need to change that to feet. So let's do that. We would multiply by the unity fraction where 3 feet is equal to a yard. So 1 yard on the bottom, 3 feet on the top. Yards will go away. And so it's 618 feet. And so to find the cost, we would take 618 feet and multiply by $16 per foot. Feet will go away, and we're left with $9,888 that will cost to build this fence. The cathedral ceiling in a family room creates 2 opposite-facing walls, each with the shape and dimensions shown in the figure. This is very similar to the measurements that would be in my house that I'm building. The homeowner wishes to have them surfaced with textured drywall, not textured, at the cost of 59 cents per foot. what will be the total cost for the two walls? Well, the first thing that we want to do is change each of these measurements into a decimal, because trying to deal with feet and inches in the same problem would be difficult. So 11 feet 9 inches would be, we're going to change to feet because we're going to deal with square feet there. So 11 feet plus 9/12 of a foot, or 11 75/100 feet. We'll do the same thing with the other two. There we go. Okay, the next step is to find the area. There's our measurements. That is the height divided by 2 plus or times the sum of the bases. The height here is the distance between the bases. Now, this is not the base, even though it's on the bottom, okay? The bases are the two parallel sides. So the height is the 10.5 feet. And then one of the bases, doesn't really matter which one you put first, is 11.75, and the other is 8.25. $10.5 divided by 2 is 5.25. And add those, and we have 20 feet even. Multiply, and we have 105 square feet. So we're almost there. There are 2 of these walls that they're having to cover. So first, we're going to multiply 105. I have another page. Yep. By 2. And that's 210 square feet that we have to cover with this textured drywall. So to find the cost, take 210 square feet and multiply by 59 cents per square foot. Square feet will go away, and we just multiply 210 times 0.59, and we get $123.90 for the drywall. Last example says a square hot air duct must have the same area as 2 rectangular ones with dimensions 5 inches by 8 inches and 4 inches by 6 inches. This sounds very familiar. How long are the sides of this square duct? Okay, so we're focusing on a square, and it's got to have the same dimensions as a 5 by 8 and a 4 by 6. Okay, so we need to find the area of each of these. The first one is 40 square inches, and the second is 24 square inches. Add them together. (64 square inches). So the area of our square duct has to be 64 square inches. Now remember, you can find the length of a side by taking the square root of the area. So that's what we'll do. Take the square root of 64 square inches. Square root of 64 is 8. The square root of square inches is inches. And so each side measures 8 inches. And that concludes our section.